Okay, guys, so let's start. So this batch is about your TCP. Okay, actually we have to cover TCP IP. So actually this batch is about TCP only, guys. My planning is to cover like the following topics in the upcoming within 1 month only. That is just for the interview perspective. Like first of all, we will cover about the TCP IP. After that is about UDP. After that, it's about IP. This one IP is okay. Then about SSL, only SSL. Okay. Then about your IPsec. First, we will cover IPsec. After that, we will cover SSL. Okay. So into that, it's not like that. I'm going to explain all the VPNs and all that. If I'll start with the IPsec, it's not like that. I'll explain DM VPN, get VPNs and all. No, that is not there. My concern is about if there is a two sites, site A and site B. So after that, if we are connecting any VPN or if we are configuring any VPN between that, so how many type of headers? Okay, like according headers perspective, totally. I'll explain over there. Then it's about SSL there, same SSL packet headers and all. Recently CSS code came and they were asking about mostly SSL and IPsec there. Okay, and almost 90% student they got like they didn't select it. The reason is they didn't have that much knowledge about the SSL and IPsec at the like packet level there, so they got rejected almost. So TCP is the very basics for every interview. Maybe you are going for the routing and switching, maybe for the securities and all. So TCP, they're asking. So first focus our should be only TCP and IP over there. So first is even maybe mainly about TCP. So after that, when I'll complete these things there, then after that 1 week for the about HTTP and about HTTPS. Even HTTPS we will cover during the part of the SSL only. So, but still we have four different type of packets into that. Like if we are using any HTTP protocol, like about what about the get, post, so many processes are there. So that we will discuss there. After that, into this one, domain name system, DNS about that. Then about FTP, okay. Then about TFTP over there. Then about RDPs and all, how to take the RDPs, what are the traffic flow and all. About SMTP, okay, and about SNMP there. So these are the basics protocols, okay, or basic things. Mostly in the interviews, they ask the questions from these things also. Because as it's happened with so many students, so I like that they are just doing the CCI training, and they are thinking that once they will go for any interview, so directly they will ask them about. Just 1 second. So mostly guys who's in the CCI, they are doing the CCI training. So security I'm talking about. Mostly this problem is coming with the security guys. Once after routing and switching, they are coming with the security classes. So they are not keeping their focus on the basics. Basics means I'm talking about even about TCP, about OSI, about ARP, about JARP and all. If we are asking these type of questions to the security guys, so on that time, the mostly 90% student they are not aware about these things. The reason being is obviously we are not in the connector, we are not in the like touch with all these things because this is about the routing and switching and all. It's not the part of the security, but still guys, for interview perspective, because in this CSS course, to so many students they called me why they are asking about these questions. This is for the routing and switching guys. So this is routing and switching. It's not like that. This is not the basics. This is the basics only. Okay, so please try. If you are in a security, that's good. Okay, security products they will ask you. It's not like that you are going for the interview and in the first round only they will start with the directly FTD. They will ask you about ASA, they will ask you about ICE and all. It's not going to happen over there. So first of all, the first 1 or 2 rounds maybe they will ask you about the basics only. And same thing is like like CSS Corp is doing right now. They're hiring for the Palo Alto project. Like even they are not asking in a single question from the Palo Alto. They're asking about same ARP, GRP, DHCP, DNS and all these type of basics. And we are not putting our focus on these things there. Okay, because after routing and switching, we are not touching all these things. Even it's in the CSS Corp to the 2 students, okay, because we got the feedback from the CSS guys. So they asked even subnetting question. Okay, we need two hosts in a network over there, so what is the slash value? And on that time, that those guys, they were giving /24 /25, these type of answers there. So guys, these things are very, very basics for any network engineer. Maybe you are in the routing and switching, maybe you are working in a collaboration, maybe you are the part of the security team. That doesn't matter, guys. Okay, so because of that reason, so many students calls and all, so that's why I'm just going to start all these things. So this is the first week, even first day. Okay, so the focus should be on the TCP. So I'm not sure how much time will it take. TCP depends on your basics. If you are good with the basics and all, maybe we will finish this TCP within 10 hours. 10 hours means daily 2 hours per day, Monday to Thursday. Maybe sometime it's like Monday, then it's about the Wednesday, then about the Friday, and then about the Sundays. Okay, like that only I'll take the sessions, because I have some other batches also. So somehow I'll just adjust this batch. Okay, and then I started this batch only. So daily, right now, today we have session, then tomorrow also we have session. So I'll try to take like Monday to Thursday, but in between, if it's required, okay, maybe if I have to postpone the session for a day and all, so maybe I'll do that thing. So TCP actually main thing is key. I'll try to finish it between 15 to 20 hours. Okay, actually I'm considering 15 to 20 hours when I'm considering that you don't have this, you have the zero knowledge. I'll consider it everyone as a from zero, and then I'll start it. So maybe it will take 15 to 20 hours for that. So maybe almost 7 to 8 to 10 classes over there, 2 hours per day. Okay, so this thing we have to cover there, but let's consider maybe if you are good in basics and all. Okay, because once I'll start depends on that. Okay, I'll ask you so many questions if you will reply. So obviously maybe on that time we will be able to finish 8 to 10 hours as well, depends on that. So today is the day one, and we will start with the very basics. Even we will start with the OSI and TCP stack comparison. What is the meaning of that thing? If I'll show you the syllabus, so this is the syllabus, guys. Okay, I have divided into different sections. This is the overall syllabus of the TCP. First is about section A, that is about the introduction. What is the TCP, why we need it, what is the OSI, what is the TCP, like TCP IP stack model over there. Okay, so all these things. So this is about the day one. We will start with this thing only. Day two, we will start with the three-way handshake process. Why do we need the three-way handshake process? I hope, guys, everyone is aware about that. What is the three-way handshake process? Okay, so to establish the connections and all, sometime we have four-way handshake process also. What is the meaning of that? So this is the syllabus, like what is the TCP? Okay, what are the sockets? What about the segments also? I have to add here. TCP connection can be happen by the three ways, or three-way handshake process. Active open, what is the active open? What is the passive open? Okay. Same time we have to explain ISN. This is about your sequence number. I hope, guys, you have covered your sequence number and all. Okay, sequence number, acknowledgement number, about the TCPs and all. What is the open? Okay, and what is the three-way, four-way handshake process? What I explained, TCP half close over there. So these are the very basics and the three-way handshake process. Okay, all these things we have to capture. Okay, so we will do one thing. As a lab, we have to take two routers we will use, and in between that we will establish one TCP connection. Okay, so on that time we can use the telnet also, we can use HTTP also, we can use SSH also. Just we need three-way handshake process. At the same time, we will discuss about the fin as well. What is the fin process? Finishing over there, how to close any sessions. So again, same, we have the three-way handshake process into that, or we have four-way handshake process. So these two things we have to discuss, and these things, guys, maybe will take your 2 days actually. One day today's introduction, and this is about the 2 days. So many things we have into this one that we have to discuss. After that, TCP segment creation over there. Okay, guys, what is segment? Yes, guys, please reply. What is segment? Any idea? Guys, can you hear me?
A block of TCP data that is getting, like, to communicate with to transfer the packets, TCP packet, that is called a TCP segment. or the window.
Okay. What about other guys? Data bytes. Okay. Transport layer. Okay. What about other guys? One or two guys are replying. L4. Okay. Okay. What about other? Okay. So segment is, you can say from the different definitions, splitting a computer network into the subnetworks. Okay. Chunk of the data. Okay. In the transport layer, data in the form segment. Okay. Done at the transport layer. Okay. Yeah, this is the type of PDU you also can say. Okay. Protocol data units. Because on each and every layer we have the different PDUs there. If you will use PDU keyword word, that would be better actually. So PDUs means we have the deluxe form of the data on the each and every different layers there. If I'm talking about L7, L6, and L5, what is the PDU we are using? Data. On L7 we have segments. We have datagram also, that is about related with the UDP. Then we have on the L3 layer we have about packet. Then L2 layer is about frames, and L1 is about the bits over there. So that is about your PDUs, packet data. Okay, unit there. We will discuss all these things again. So the thing is, what is the biggest segment I can create and how many segments I can send at the same time? How to turn streams into segment? What is the send call? What is the Nagel algo? What is the go on? What is the largest segment size can be there? Okay, we have to go with the MSS there. This is the one of the option. Maximum size, maximum segment size. Explain Windows concept. Okay, and then about the scaling concept here. So again, guys, these factors will take maybe 2 days there. Okay, because first two, these sections are very important there. Then we have transition state. It will take 1 day only. Transition state means, let's consider if I'm just trying to establish one three-way handshake process between two devices. Okay, so when we are just trying to establish an TCP connection, okay, this is the first sync, then sync plus add, and after that acknowledgement. So many states are there, states, transition states over there. So we have to discuss about those states over there. That is also very important from interview perspective. Okay, that is, this will take 1 day. Okay, 2 plus 2, 4. One is here 5. One is this one 6. Then about missed acknowledgement, retransmission, SAT, and the timeout. So these things will take again 1 day. Reset segmentation. Okay, if we have reset concept over there, okay, why? So what is the reset? Why do we need it? Okay. So all these things we have to discuss. Then we have to discuss about the flags. There is so many flags are actually not so many, only 6 flags are there. So like about sync, ACK, reset, push, urgent, congestion mechanism. Into that congestion mechanism, we have one more segment that also we have to discuss. Then about congestion control mechanism. Okay, like about slow start, very important from interview perspective, guys. Slow start, they're very important. Fast retransmit, fast recovery, congestion avoidance, and all. So all these things we have to cover through. Then TCP options. If you remember, okay, in TCP header, okay, in the last one, in the bottom one, there is a one field is there, and that field is known as options. So in the options, so many things are there, like about MSS, maximum segment size, SAC, selective acknowledgement over there. This is the WSO-POT. This is about some optional concept we have. This is about window scale. W scale means this is about the window scaling. Timestamp options. PAWS means about protection against wrapped sequence number, user timeout, authentication timeout. And in the last section, we have is about TCP keep alive messages. Okay, so guys, all these things we have to cover. So I think it's gonna take almost your 8 to 10 classes, means about near about your 20 hours. Okay, so I'll try to finish this batch. Okay, not try to, okay, try to finish this week only, because from coming Monday 11 o'clock I have Palo Alto batch. So or otherwise, if it's not possible, so I'll do one thing, I'll postpone that Palo Alto batch, and then we will continue with the same TCP session. Okay, one more thing, just guys, I just want to ask you, Is that possible ki if I'll change that some time and all, like a work? Okay, we will discuss later, not now. Maybe in the next week we have to change the time. So that we will discuss in the next week only. So guys, this is the syllabus which we have to cover. Okay. So we will start from here only. So guys, if you have any doubt, if you have any question regarding the syllabus and all, if you want to add something, let's say maybe some of you are working and all, maybe if you know and if you want to add key, okay, this maybe this topic or this topic is also should be discussed here, so that you can tell me over here. Because according to my knowledge, yes, one book I'll tell you, no problem, Thirumalai. I'll give you one book as well. Okay.
So can you give us a list of all the topics that will be asked in the interviews? Like this, you mentioned for the first 3 weeks, like TCP, then SSL, then EPSEC.
Right
So
now, I don't have anything specific things over there. Okay.
okay, okay.
So,
So
but
after
according to
this,
my knowledge, whatever is the possible
right,
questions in the TCP in the interviews, okay, that I'm covering here. Okay, this is max to max. So after that, beyond these things, okay, they are not gonna ask you anything. But let's consider if some of you are working, you have like already attended so many interviews and all. Maybe if some questions are there, some scenarios are there, so you just tell me. I'll practice on that, or maybe we will try to solve that.
will you be taking interview sessions on like appliances also, like FTD, ASA,
No, no,
NGIP,
no,
SIC?
no, 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 no,
Okay, okay.
no. Actually, so many students they called actually, Miki sir, we need TCP sessions and also that's why I started this thing.
Ah, I see, I see. Okay, okay.
Okay, because they were facing the issues. Okay, so even I took almost like 2 or 3 session of the some students there. They had interview in CSS and they got cleared actually. So,
Okay, okay.
but after that I thought, okay, let's start one session. So that's why I'm starting the session there. It's not
All right, understand.
official session. Ki they just assign me a batch and all. Just from my interest, I'm taking it. That's it.
Okay, okay. Yeah.
So guys, if you know some questions and all about the TCP, some maybe topic which is important from interview perspective, because I have done so many R&Ds and all. So from finally I got all these topics, and this is according to me, this is more than sufficient. Okay, but still, if you have questions and all, so just let me know. I'll try to cover that thing also. Okay. So guys, if you have any question, if you have any doubt, anyone, so you can ask me. Book I'll upload into the like one drive I'll create as usually. So I'll upload the one book over there. Okay, I'll show you the book also. So before that, guys, any questions, any doubt, anyone? Okay, guys, just give me 1 second. Okay, I'm just coming back. Please be on it. One. Okay, guys. So one book I'll show you now. That book you have to prefer. I'm not gonna share any PPT and all. Okay. So one book I will share with you that you can refer. Oh, where is that? Yes, this is the TCP book. Okay. Actually, this book depends on you as well, but I like this book because into this one, so many things are there. Okay. If you will go through this book, okay. So this is about introduction of that. Okay. About internet address architecture over there, link layer. According to layers, there are the chapters, address resolution protocol. All the maximum possibilities are here about the ARP and all. You can go through that. Internet IP, about DHCP auto configuration. This is about DHCP chapter. NATing information, about ICMP v4 and v6 also. Both the ICMPs are there. This is into totally depth there. It's up to you. Okay. It's about ICMP and NMLD. Multicasting. This is about the UDP and IP fragmentation. This is about domain name system DNS. This is about the TCP now. So from here only, the first chapter is TCP, then about TCP congestion connection management, then about TCP timeout and retransmission, TCP data flow and window management, TCP congestion control there, okay, and TCP keep alive. So I have made these PPTs and all according to this book only. This book I will share with you, okay. Tomorrow I will share with you this, okay, so then you can refer this book here. I have made one specific, one different PPT also I have, that is for you only, that I will share with you. And this says I'm talking about, guys, please mute your mic if it's not required. Sonika, who's that? So this is TCP here, PPT, this is the one PPT. This is for you guys only. This is about the headers and all. Okay, so many headers is required in the TCP and all. So many diagrams are there. So like about TCP header and encapsulation, TCP header, all the typical that you can use it, guys. Okay. What happened? Shit. Can you see now? I think screen is visible. Okay. Yeah. Okay. So this is the one of the PPT, guys. This is for you only. This I will share with you. Okay. Still, I'm working on this PPT. Maybe within 1 or 2 days, I'll complete it. Okay, because so many things are need to be added there. Okay, but these are the basic things which I have already added into that. Okay, like about window sliding. Okay, and about urgent pointer, which is very required. So with the diagrams and all, I have uploaded. Okay, so these are the some finite state machine. These are the some states of the TCP there, okay, which we have to go through that. Okay, this is about the state machines and all. Okay, so guys, all these things we have to cover. This PPT, only single PPT I will share with you once, maybe within 1 or 2 days. I'll be done with this PPT, and after that I will upload it on the drive. So this is about PPT book. I will upload it tomorrow. Tomorrow you will get this book, which I have already shown you. Which one? This one. This book you will get it. Okay. Now, okay. So now let's start here. Now, guys. So if I'm starting with this thing, okay. 1 second. Now, so in the first PPT, okay, in the first chapter, okay, in the first section, these are the things which we have to discuss. That is about TCP and IP model review. Then we will go through the transport layer, TCP versus UDP, TCP segmentation and header, and that about the TCP operations. So these are the basic things which we have to cover today. And tomorrow we will start with the three-way handshake process there. Okay. Don't miss any lecture because day 2 depends on day 1, day 3 depends on day 2, and day 4 depends on the day 3 over there. Okay. Now, so if I'm talking about OSI model, guys, I hope as you are aware about that OSI model. Okay. So the OSI model, these are the 7 layers. Guys, tell me one thing. Which is the what is the name of the L1 layer? Is that about application or is that about physical layer? Which is your layer 1? Which is L1, guys? Is this one or this one there? Okay. Now, good. So this is L7 layer. This is about application layer, presentation layer, and session layer. Then these are the 7 layers about the OSI. But after that, they came with a TCP/IP stack model over there, just to reduce the number of layers over there. If we are talking about these two layers, they added these two layers in the single layer over there, and that is about network access. Then about network layer, they converted into internet transport. That this is the same layer over there, and these 3 layers, guys, they are, this is as a same to same. That is about your application. One thing is there ki we have one PDU concept, which is about known as protocol data unit. PDU means that is about the protocol data unit here. If I'm talking about first these 3 layers, so what are the PDU we use, guys? Mostly we use data. Okay. If I'm talking about transport layer, we have the 2 options over there. One is about segment, which we use for the TCP, and second is about your datagram, which we use for the UDP. Third is about your network layer, that is about packet. That is about your packets here. If I'm talking about data link layer, that is about your frames. And if I'm talking about physical here, that is about bits. Okay, this is a very important. They can ask you about directly questions about the segment, about the frames, and about the packets. So these are the PDUs, guys. Okay, so after that, if I'm coming with the next slide, this is the application layer. Guess you have already covered your applications layer and all daily because you are mostly from the security. So we are dealing with the mostly with the FTD you have completed. Okay, maybe some of you are doing the FTDs, and we have completed NG-IPS, ICE and all. So if we are talking about any next generation firewall, so next generation firewall always do the filtering behalf of the L7 layer. What is about L7? That is about applications. So what are the application here? Basics intro I'll give first about the OSI, then we will go further. If I'm talking about network process of the applications here, so first is about it will provide the network services to such applications such as about electronic mails. In the mail, if I'm talking about, you can say here about we are talking about here Gmails over there, okay, Outlook.com over there, maybe redditemail.com. So that is about your emails concept here. File transfer, so many file transfer concepts we have over there, and about terminal evolutions. Then provide user authentication. So this is about your application layer, which we use here. Next, we have about presentation. The presentation layer is about data representation. That is about ensure that the data is readable by the receiving systems. Okay, because let's consider if you are opening any website, maybe some abc.com is there. So maybe you are opening this website on any laptop or maybe any PC. Maybe you are using mobile phone, or maybe you are using any tablet. The same website or same applications, maybe it could be any application also. So on all of these devices, we are able to open the same application and same, you can say websites also. Okay, so maybe the same, but can you see the font or your totally the scenario will be changed on that. And this is totally different concept here. This is looks like a vertical concept, and this is type of like little bit horizontal concepts. But data or content will be remain same. So OSI will change their format of the data or of the sites according to the requirements. Format data, structured data, it will change the structures and all, negotiate data transfer syntax for the application layer, and provide encryption over here. Okay, I hope guys you're aware about encryptions and all. Then about session layer. Session layer is about to establish the session, to manage the session, and to terminate the sessions. Let's consider you are doing any online exams and all, or maybe you are using any online banking websites and all. Okay, so maybe you're just logged in into ICICI online banking. After half an hour or let's consider you're not doing anything, and your this page is idle from last 2 minutes or last from 3 minutes over there. So automatically your session will be terminate these things. Okay, automatically that will be log out from there. So how all these things are happening? That is happening because of the session layers. Okay, So on a single PC, let's consider if I'm opening, if I'll open this one, can you see here this is my Gmail, this is my about Google Drive. After that, Zoom is going on. Maybe next I'm opening Cisco.com over there. So if let's consider after that, if I'll open LinkedIn here, let's consider LinkedIn is there. And if I'm messaging someone, so it means I'll get the reply of that message on the same page. It's not like that I've just sent one message from here, and now if I'm going to the Cisco site and if I'm looking for the reply here, that is not going to happen. LinkedIn message reply, if you are sending someone message and if you're waiting for the reply, so that reply will come guys on the same page over here. So that is meant about sessions layer only. Maybe after that Facebook is there, maybe Insta is there, maybe Twitter is there. So how these sessions are separate actually, how the PC is maintaining all these things. So actually who is responsible for that? Your session layer is responsible for that. So session layers also plays very important role. Okay, but interview perspective, this is not that much like important here. This is the main layer. Our focus should be here only. That is about the transport layer. What is the transport layer? Transport layer actually, it's very simple. Let's consider this as me, and if I'm right now I'm in Bangalore, and if I have to travel, maybe I have to travel to Delhi right now. Just consider. So how many options do I have? First option, I can go via flight, okay, via air. Then about via road, I can go with the, like my personal vehicle over there. Okay, I can go via train also. So what are these things, guys? This is your transport layer. Okay, this is the transport layer. Okay, which transport I'm using over there? I'm using, there may be trains, maybe about any four vehicle, okay, maybe any taxi, or could be taxi also, could be personal vehicle also. And this is about the by air I'm going. Okay, so by air, if you are going, this is a little bit faster over there. Maybe this thing, it will take maybe 3 hours here. If you will go via maybe your private vehicle and all, will take 3 to 4 days. And if you will go via train, it will take you almost 36 hours there. So these are the what? These are your transport system, guys. So same from one device to another device, if we have to send any data, so which transport you are going to use it. So mostly actually transport layer is responsible for that. Okay, so there are actually two main protocol for the transport system. The one is first, and one is about TCP, and the second is about UDP. So these are the mostly two main protocols, transport protocols we use actually. Okay, so transfer the data from one client to the another client. Actually, when we are talking about transport layer, so according to transport layer, actually transport layer always consider key, this is your end-to-end connection. Actually, according to transport layer, there is a no network layer, no data layer, nothing is there. According to transport layer, they consider that we are actually directly connected. Okay, these are the two devices and we are directly connected, and we are just talking from transport layer to transport layer. Actually, but it's not like that. We have network layer also, we have data link layer also, and then we have physical layer. Okay, so once we are going via train or via flight, it's not like that at airport only we have to stay. After that, again, we have to travel locally as well. Okay, so this is that type of concept. Okay, so if I'm comparing with the actual transport system, so you can say, yes, if we are talking about transport layer, on the transport layer, we have two main protocols. The first is about only two main protocol. First is we have to discuss TCP, and then this is about the UDP. TCP is your better as compared to UDP. There is so many reasons for that, and those reasons we have to discuss actually why TCP is better as compared to UDP. UDP is more faster as compared to TCP. That's why all the live sessions and all, everything mostly happens on your UDP there. If you are watching any online, if you are playing online games, maybe if you are watching any like live cricket match, or maybe any live event is happening and you are watching it like live. Okay, if some event is happening and you are watching it live there, so almost everything is about on the UDP there, because UDP is more faster as compared to TCP. So many reasons. That's why we have to discuss those things. So can you see it's always about end-to-end connections here. handle transport issues between the host, ensure that data transport reliability, okay? So establish maintenance and terminate virtual circuits, okay? Provide reliability through the fault detection and the recovery information and the flow control here. When you are traveling via flight, or maybe you are traveling via train, okay, or maybe you are traveling via your personal vehicle. So if we are talking about security perspective, so via air when we are traveling, so that is more secure. Okay, because so many like securities are there and all. If we are traveling via train, so as compared to this one, maybe that much, if the train transport is not that much like secure as compared to this one. And if you are going via personal vehicle, maybe that is not like that much secure as compared to TCPs and all. So reliabilities of the transport system, okay, which transport are you using, how you are traveling, maybe if you're going via plane, so after that according to services, maybe you are choosing Vistara, maybe you're going via uh, Air India, or maybe you are going via some another airlines over there. So that's depends actually. Okay, who is this guy? Okay, now, so this is the transport layer, and our focus should be on this one only because we are doing the TCP. But just once I'm going through the network and data link layer also. Let's go through that. So this is about the network layer. Network layer is about the data delivery, about route data packets, select the best part to deliver this one. Let's consider transport. You have selected, okay, I'm traveling via my, okay, maybe you have decided that, okay, I have to travel, I have 4 vehicle, and just consider I have to travel now. From Bangalore to Delhi, I have to travel via my own vehicle. Maybe it's about 4-wheeler, or maybe it's about 2-wheeler, depends. That you have decided what you have selected here. If I'm talking about 2-wheeler, which is about bike, and if I'm talking about the 4-wheeler, which is more secure, obviously the 4-wheeler is the more secure. So out of these two, out of UDP and TCP, I have selected, okay, I'll go via 4-wheeler there. But how to reach, what is the path, like how, like should I start and all. So on that time, guys, which concept will come? Network layer concept. Okay, IPs and all that. Okay, okay, first of all, from Bangalore, you have to go to the Indore, then Indore to like further process. Okay, after that, like that is the traveling path over there. So you can do the Google, you can use Google Map also, or maybe if you have already traveled so many times, so you are aware about the paths there. So how we are selecting that path and all, that is about your network concept. Because from one device to, let's consider this is the device, host 1 and host 2, and we have to start the communication between them. And these are the different routers. Not here. Let's consider this is the host 1 and this is the host 2. Okay, and we have decided we are going to use TCP here, and these are the routes. Okay, different routers over there, and they are connected like this way over here, this way, and maybe this router, and this is like this way. So the thing is, okay, you are using, now I have decided, okay, I have to use 4-wheeler, and this is that 4-wheeler, and I started my journey, and now I just came to this point, and now from here, how many paths do I have? I have the 3 options: option 1, option 2, option 3. So which path should I select on that time? Should I go with the path 1 via path 2 via path 3? So then I have to find out shortest path on that. So what is the concept then we have to use? Then routing protocols concept will come in the. Okay, so then we have to use that concept over here. So this vehicle, what are the transport you are going to use if you have to decide this thing? So for that we have the 2 options, UDP and about TCP. Depends then. So this is about the network layer, then about the data link layer, access to the media. This is about your MAC address concepts. Define how data is formatted for the transmission and how access to the network is controlled. and provide your all type of error detection and all. Okay, so on the data link, actually error detection plays very important role, because on the network layer and the transport layer and on the session, on the presentation, we don't have any error checking concept. Error checking concept we have always on the data link layer. I hope you remember one field is there that is about FCS. Full form exactly I don't remember now, but we have one field on data link layer. On the data link, we have one Ethernet frame. Okay, so in that frame, we have one FCS. What is the FCS? First of all, your checksum will be happen, and that result of your error checking concept will be saved into your FCS concept. So FCS is a very important concept. In interviews also, they are asking you, okay, what is FCS, on which layer the error, detection and error correction concept is happening and all. So for that thing, guys, we have to go with the data link. So this is also very important from interview perspective. And then finally, and the last layer, okay, is now about physical here. Yes, frame check sequence. Correct. I'm not good into this full forms and all, so that's fine. So the physical layer, if we're talking about, so physical layer is about binary transmissions here. So define the electrical, mechanical, procedural, and functional specification for the activating, okay, and maintaining and detecting the physical links. This is about always about physical layer here. So these are the layers, guys. Okay, I know you have already gone through all these things and you are aware about that. But in the starting, I had to start with this one, so that's why I started. So this is about your basics introduction of your OSI model. Okay, we have to work on this layer, and this layer here, L4 and L7 layer. This is our important concept from the interview perspective. Encapsulation, guys, I hope you are aware about encapsulation. Encapsulation means, just consider this is the user data. User data means, hi, this is the data, and I just want to, this is the sender. So this is the user data. So from the user data, let's consider I'm using HTTPS. This is my message, hi, and I have to share with my one of friend. Okay. So first of all, on L7 layer, I have to add HTTPS header. After that, on L6, we have to add L6 header, then L5 header, then L4 header, then L3 header, and then L2 header. And finally, it will be converted into the bits. And once it will be converted into bits, after that, it will be send this particular data. And this is considered, this is one of the cable here, RHIP. Okay, any cable you are using. It could be fast Ethernet, could be Ethernet, could be Giga Ethernet. After that, this data, actually this one, which we have converted, this layer converted into the form of the bits, that is converted, and after that, it will be replicate that this data on this particular layer. That means this layer will push this particular data, which in the form of the bits, on your this cable, guys. Okay, so after that it will travel here, and now finally it will reach on your L1 layer on the receiving side, because data is traveling via cables always. Okay, so this is the encapsulation process when it's handing your all the headers. And if I'm talking about reverse one, reverse is about de-encapsulation. Okay, it will remove one, it will first it will reach to the your, can you see on L2 layer we have FCS concept. So this is the sender, and if I'm coming about receiver, this is the receiver now. Direction change. Before that, this was the direction, and now this is the direction. In this direction, first of all, they will list bits there. Okay, bit they will convert into this format, then they will remove L2 from the L2 header, then L3 header, then L4, then L5, then L6, then L7, and finally your data. So this process is known as about your de-encapsulation. TCP and IP stack. This is about, I'm talking about the same thing we have discussed. They just merge all these layers into the single layers over there. Okay, so that is about the three layers they added and they merge into this concept, and last two layers they merge into this one. This is about your physical and about the data link layer. This is about your application and about your presentation and about session layer. Transport layer is same, and this is about your network. So this is all of these things that theoretically it's mentioned here, nothing else. Transport layer, because the main focus, our main focus should be on the transport layer. Now, because we are doing TCP. Now, so see, if we are talking about transport layer roles and the services, okay. Now see, first thing is that key why on the TCP layer, okay, on the transport layer. First is station establishment, management, and termination concept is there. Name, okay. Next is about segmentation of the data. Windowing will play a very important role on the TCP. Addressing of the upper layer application using the ports number case. Okay. See, if we are talking about at this layer, if I'm talking about during the de-encapsulation, so L2 is removed, my MAC address concept is completed, L3 is removed, now my IP address concept is done. The thing is, in a single browser, if I have opened different sessions, okay, so the thing is who will maintain all these sessions? Actually, this is the session number 1, session number 2, the session number 3. So how they're gonna keep all these sessions separate? Who is responsible? Session layer. But the thing is how session layer is gonna be keep all these sessions like separately over there. So what the things actually IP address is not gonna be used, okay, because that is already removed. This is also removed here. So who will help on that time? Port number concept. Okay, so the port base, and actually who's the port is concept about what? L4 layer. So it means L6 layer actually will use L4 concept to keep all the sessions separate. How it will do that we have to discuss. Now, after that, this is about the addressing of the upper layer applications using ports numbers always. Sequencing, very important prospect concept here, okay, from interview perspective, very important concept. Flow control, very important again. Multiplexing, it's not important according to interview. Error detection, support for the reliable and unreliable data delivery mechanism through acknowledgements. And which two protocols we use here? TCP and UDP. Okay, so this is here mapping transport to the applications. Actually, this is gonna happen behalf of your port number case. Okay, see, if I'm talking about port number, first let me discuss about the port number. If we are talking about ports numbers here, so actually this registered port and dynamic ports are same now. Before that, it was a different actually. Well-known port numbers means about the port number which is reserved, guys. What are the ports number reserved? If I'm talking about telnet, if I'm talking about SSH, if I'm talking about FTP, if I'm talking about DHCP, so many ports numbers are reserved, guys. Telnet port number 23, then 22 for FTP, 20 or 21, then DHCP for that. Okay, it's about 67, 68. This is for the UDP over there. Okay, so like that, so many flex port number 80, then 443. These ports are reserved actually. So this is known as your well-known port number here. Almost 2 years back, actually, before that, actually, if I'm talking about 2 years back, so registered port number and dynamic port number was a different concept. But now what they have done, actually, they have merged both the things now, and from 1024 to the 65535, these are the right same dynamic port number case. These are all the dynamic port number case. If I'm talking about IPv4, how many bits are there? There is a 32-bit concept. V6 is about 128-bit concept. And if I'm talking about port number, that is your 16-bit concept. In CSS, they asked this question, and some student, they were not able to give the answer of this thing as well. They asked, if we are talking about port number, so how many bits are there? They asked this question, and after that, some told like 32, someone told 48, like that. So actually, guys, this is about the 16-bit concept. 2 raised to power 16. If I'm talking about bit concept, so that is about 2 raised to power 16. That is about 65,536, but it's always start from 0. So ends with 65,535 over. It's about 65,535. Okay. So this is now divided into two parts. One is about well-known, which is about 0 to 1023, and then about 1024 to 65535. They can ask you this question also, depends. Okay, so this is about now your random port assignment. About random port. This one. Okay, so if we are talking about this is the mapping transport to the application layer. So can you see here? This is about FTP, board number 21, Telnet 23, STTP about 80, DNS about 53, this is about TFTP, and then it's about SNMP. Okay, this is about the transport layer, and they are mapped with application layer. 23 is just for the Telnet only. So this is the port number which we are using on the actually transport layer, but it doesn't mean that Telnet actually we are using on L4 layer. Telnet is in a protocol which is on application layer. Telnet, maybe SSH, maybe STTP, maybe HTTPS there. And for transport, actually, they are acting as a services. They're acting as a services. Okay, 23 services going on. So what are the 23? 23 is related with your Telnet. On application layer, Telnet is acting as a what? It's acting as a your application. Okay, this is one of the application. STTP, sorry, protocol. STTP, these are the what? All these are the protocols actually. But when we are coming down and we are talking about L4 layer, so all these are will act as a actually your services. Okay, how many services do we have? If we are talking or if we are asking to the TCP and UDP. So TCP is what? Actually, TCP is nothing. This is in a type of box actually. It's in a type of box. Same UDP is also type of what? It's in a type of box. TCP, this is what? It contains so many services like Telnet. Telnet is not in a protocol on L4 layer, guys. So students always confuse. Okay, the Telnet will act as in a protocol for the L3 layer, L4 layer. Sometime in interviews they're asking, okay, on L4 if we are talking about Telnet, so Telnet is using what? Port number 23. So on TCP, is this in a protocol? So the answer is students they are giving yes, this is in a your TCP, and TCP we are using on which layer? L4. So the students they are giving on that time answer ki yes, Telnet is in a protocol which we are using on L4 layer, and L4 is using 23 port number for that. So guys, no, TCP it's not a protocol for the your L4 layer. This is protocol, or you can say an application for the. This is one of the protocol. Okay, or SSH is in a protocol which we are using on the application layer. For the SSH and for the Telnet, which application do we use? We use PuTTY over there. Okay, PuTTY is an application, okay, which is we are using on the application layer here, and for that, which protocol we are using? SSH, and we are using Telnet. And if we are using on L4 layer, guys, that is the concept of your services. Okay, which service are you using? Because TCP it's in a box. Okay, which contains so many services like 23. This is about SSH, port number 22, STTP, port number 80, HTTPS, port number 443, then about FTP, about port number 2021. UDP if you are talking about. So in the UDP about DHCP 67, 68, 67, yeah. Then about 53, this is about your DNS over. So like that, these are the what? On transport layer, it's acting as a guys services, not as a protocol. FTP, Telnet and all these are the not your L4 protocol. These are the application protocol. Okay, and what are the application we are using for FTP? If I'm talking about what are the like application we use, FTP is in a protocol, okay, for the according to L7 layer. So what are the protocols do we use for that? Oh, sorry, application we use. We have one FileZilla for that. This one here, FileZilla. Okay, from this one you can use your this one. FTPs and all, you can use VNSCP, like VNSCP is also there. In the VNSCP, if you will open, so many things you can do it, like consider file protocols, SFTP, then SCP, FTP, WebDave, Amazon S3 over there. So these are the what? These are the protocols. Okay, and these are the application which we are used for that. In PuTTY we use for the Telnet and SSH. Okay, so these are the what? These are the application. Okay, so this is the mapping here. The transport layer divide the data into the pieces and add a header for the delivery. This thing we will discuss during the deliver option over there. So this is the application layer. Okay. Yeah, I am here only. Okay. Now, so now this is the application here. So this is about the TCP segment, and can you see this is the UDP datagram? Or see, students always confused. Always they are saying ki sometime, okay, it's happened in front of me as well. In the January one company came L3 Harris, and in interview, some student they were saying ki UDP all uses your segments there. So guys, don't use like this way. UDP is always about datagrams, not about segments. Okay, this is not about the segments there. Okay, this is always the confusion. Okay, sometimes the student there, sometimes it's happened they use like this way, UDP TCP datagrams. And if we are asking do you know what is the difference between datagram and the segment, so on that time their answer is datagram or segment is the same thing, we can use anything there. Guys, it's not like that. Datagram is a different thing. This is datagram as in a PDU. Okay, for what? Okay, so it's in a PDU, okay, which we use as a datagram. Yes, for the data exchange only, correct. Okay, so this is what? This is a PDU, and for the UDP we have the different PDU, and for TCP we have different PDU. Okay, so this is the data fragmentations and all it's happened. So we have to discuss actually all these things. Guys, tell me one thing. We are always saying that TCP is more reliable. Can you hear me now? Now is that fine? Harry and Pradeep, is that fine? Okay. Guys, see, we are always saying that your TCP is more reliable for the as compared to UDP. What is the reason for that, guys? Tell me. TCP always uses acknowledgement concepts. That's good. Okay. This is actually an establishment and all this thing. We have to discuss it. I'll come on this PPT again. It's not like that I'm finishing it, because these are the things key, because I haven't started any practical. Once I'll start the practical during packet capture, we will discuss all these things. Okay. So this is nothing, just for the one thing I just want to show you here. This is like this way. Okay, if we are, let's consider this is the client and this is one of the server. So if we have to transfer the data with the help of TCP or UDP, so IPs and all that we are using, that is okay. After that, we are using source port and destination port. Source IP, destination IP. Let's consider this is 10.1, consider 10.2. And if I have to go with HTTP service, or maybe I have to go with HTTPS there. So source IP 10.1, 10.2, source port is about your any random port number. Okay. And this is destination port, could be 80, 443. Okay. So the same thing I have mentioned here. Okay. This is the server. Okay. Client request for the TCP server. This is HTTP request. Source port is what? 49152, and this is 51152. Destination port 80. This is about 25. Okay. So HTTP means which services we are talking about? HTTP, and 25 we are talking about SMTP, simple mail transfer protocol. Okay. So client sending TCP request. Okay. So this is that concept, and after that it's replying back. So during this is the request. First of all, this portion is the request. Source port is what? Random, and destination port is non-one, which is about 80. Same it's happening on this side. Source port is random and destination port is 25. And when reply is coming back, that black part, can you see the source port is from here? The source is 80 and destination port is this concept. Okay. So this is the basics diagram I have designed here. Okay. That's it. Nothing else into this one. UDP and TCP, if we are talking about their comparison, guys, for the TCP, the first and the best RFC, according to me, depends on you, that is 793. So this is the best RFC actually for your TCP, that is about a 793, which you can use it. Okay. So the thing is, what is the difference actually between TCP and UDP? Why TCP is more reliable, more better as compared to UDP? Can we tell TCP is a connection oriented? Yes, you don't have to tell. Actually, TCP is connection oriented only, and UDP is connectionless. I'm considering as here you are already aware about OSIs and all. That's why I'm going a little fast actually. Okay. Because you have already covered now, so that's why I don't want to waste the time on that. I'll finish overall the differences between all these things, and then we will start within the packet level. Now, the TCP is about RFC 793 you have to follow. Okay, if you want to use it RFC, so you can go with RFC, this one 793. TCP is your connection oriented. What is the connection oriented concept? We have three-way handshake process. Three-way handshake process means, what is the meaning of that? Let's consider this is you and this is your friend. Okay, and now you are thinking that okay, let's go for the movie, and without asking your friend is or she is available or not. Maybe let's consider today's Friday, and you are planning okay, in the evening 8 p.m. we will go for the movie, but only you decided this thing. You didn't ask your friend, okay, he or she is free or not. Maybe your friend has some another plans over there. So without asking if you will book the 2 tickets and all, everything you have booked, and after that you're calling him or her, okay, let's go for the movie at 8 o'clock. That is not a good idea. Or is that a good idea, guys? According to me, it's not a good idea, because first we have to ask to him, is that guy is free or not? Maybe he or she is already busy, or maybe already this guy has some plans there. So if this guy will say, okay, no, I'll be not able to come. So what is the meaning of this to you? All planning, whatever you have done, that is gone now. Okay, so the better thing is that you first call your friend and ask, are you free in evening at 8 p.m. over there? So if yes, so then book the ticket there. So this concept is known as what? Your connection oriented. So in the TCP, before transfer any data, let's consider this is the client and this is the server. And you have to download something, or maybe you have to transfer some data, maybe client to server, or maybe server to client, doesn't matter anything. So let's consider my thing is I have to download from here. So this is the client, this is the initiator, this is the responder. So first of all, we have to go with the three-way handshake process. So first of all, I'll send one packet, and that is sync. And I'll ask, hey, are you free? We are doing some planning over there. Are you free over there? Okay. So the answer is, if this is free, if this guy is free, yes, I'm free over there. So then the reply will be as a sync plus ah. This acknowledgement is behalf of this sync here. This is the thing if it's free. And the second option is if not free. Maybe this server is on this server, so many connection TCP connections are already established, or your server is already full over there. There is no space for any new TCP connection. So on that time, the answer will be negative acknowledgement. Okay, sorry, I'm not free. I'll just catch you later over there. Okay, so this is negative acknowledgement. So I'm not discussing right now about the negative acknowledgement. I'm not coming on this one. My concern is about yes, if server is free. So if the server is free, so after that, this is about sync plus I, and after that, the third packet will be about third packet is about acknowledgement. So when we are talking about acknowledgement, so this acknowledgement is, guys, related with the this sync. So the this sync, this is acknowledgement. Now this guy is also sending sync. Okay, I'm free. What about you? Are you free on that time? So this is your acknowledgement. Yes, I'm also free. So now both the things, both the sides are free now. This is, and after this three-way handshake process, guys, your connection will be established. And after that, you can transfer your data. So before sending any data from one client, or means from one device to the another device, okay, if we are just asking are you free or not, before making any plan with your friend, okay, before doing the booking of any type of tickets and all, okay, so if you're asking your friend are you free or not, are you interested or not, if you're asking that thing, that concept is known as connection oriented. And UDP is not doing all this thing. UDP, what actually UDP does, UDP immediately, it will not ask you, are you free or not, or nothing. No formalities, nothing is there. It will not waste the time. Actually, it's not wasting, but UDP says that this is wasting of time. Why you are asking? Just send the data directly there. So on that time, without any establishment of the data, UDP will send the data like this way. No three-way handshake, no acknowledgement, nothing is there. So now, if there is a no three-way handshake process, just consider there is a two diagrams that we're making. This is client one, server. This is server, sorry, client, server. This is TCP connection. This is UDP connection. TCP, according to TCP, first is this is connection oriented. Okay, this is not. So for the connection oriented, what will happen? Sync plus ACK. Into these packets, so many things are there. Okay, so we have to discuss. That is the only thing which we have to discuss in the class. So this is the sync plus ACK and acknowledgement. But and after that, once the connection will be established, okay, after that your data transfer will be there. This is the data, and for the each data, this is the data one, number one. Okay, for the each data, each segment, we will get what? Acknowledgement. This is TCP basic behavior. But when we are coming with the UDP, UDP says, okay, no, I'm not going to waste the time for this one. Immediately it what? One second. Directly, it will send data over. In the form of what? That is about the datagram. This is about segments, and this is about the datagrams. So this is the reason why your UDP that is faster as well. Not reliable, okay, not connection oriented, nothing. But yes, this is faster. Okay. When last time L3 Harris came in the January, so they asked, do we use UDP? To the one student, they asked, do we use UDP in the actual environment? And that guy said, no, we are not using UDP because that is not connection oriented. Guys, it's not like that. We are using UDP. Okay, all the live streaming, live gaming, whatever you are playing, whatever, all the live sessions you are watching and all, that is always happening on the UDP, live cricket match and all. Okay, so this is connection oriented, reliable. This is not connection oriented, not reliable. Connection oriented, reliable delivery means acknowledgement. Okay, this is acknowledgement. Okay, when we are sending the data from client one to the server, so for the each and every packet, we will get acknowledgement there. When we are sending the first segment one release, it's reached, immediately acknowledgement. Okay, yes, I got this segment here. Segment two, acknowledgement two. Segment three, acknowledgement three. Segment four, acknowledgement. So this is about what? This is about reliable delivery. Flow control, order data reconstruction, numbering and sequence number. Very, very important role here. Sequence number there. Flow control, regulating the amount of the data transmitted there. Error detection, stateful protocol, keep track of each and every sessions. Okay, like your ASA firewall, guys. ASA is what? That is your stateful firewall. It will connection table concept we have the same like with this one also. Okay, this is one of the stateful protocol. In interview, the question will be they can ask you this thing. Okay, can you tell me the name of the any one single stateful protocol which we use on the transport layer? Answer should be TCP. Because TCP is also known as stateful protocol, and UDP is also known as stateless protocol. If you guys know this thing, so that's good. Otherwise, try to make the notes as well. Okay, side by side. So which will keep track of your sessions. That concept is about session layer. TCP applications, HTTP, SSH, and all that. These are the applications or protocols as well. UDP, if we are talking about 793, that is about the TCP, and 768, this is the best RFC for your UDP gas. Connectionless, because there is a no three-way handshake. Unreliable, because no acknowledgement. No ordered, because there is a no sequence number concept we have. No flow control, because windowing and all that concept we don't have. I'm not sure are you aware about that or not, but we have one windowing concept, which is about your flow control concept, which we have to use in the TCP. In the TCP, flow control is related with your windowing concept. This is related with windowing concept. Okay, but not the part of the UDP here. Okay, so this is one of the UDP header. I'll show you the UDP header in another PPT. That is a good PPT, actually, this one. I hope this is visible, guys, right? Is that visible or not? Yes, it's visible now. Okay. So you can see here now. So actually, TCP have. Okay, tell me one thing, guys. Basic question: what is the size of the TCP packet? How many bytes or bits are? How many bytes are there? TCP header or IP header? What is the size of these headers? Please mention your answer in the chat box without Google. Without doing Google, please mention it. My question is, please listen it carefully. I'm asking it again. How many bytes are there in the TCP header? And how many bytes are there in IP header also? Don't Google. Okay. So if I'm talking about IP header, 20 bytes. If I'm talking about TCP, basics is about 20 bytes, but it can be vary up to 60 bytes. There is a reason for that. Okay. The reason like could be padding could be an option. Okay, maybe we are using padding, maybe we are using some options over there. Options field when we are using. Option field means I'm talking about this field. This one. So on that time it could be increased 20 to 60 over here. But basic is about 20 bytes. Okay. Sorry guys. So this is about the source port here. This is about the destination port. So actually 20 bytes, if we're talking about very basic question, I just want to ask you guys, in a single byte, how many bits are there? 20 or 30? In a single byte, how many bits are single byte? How many bits? 20 or 30? Very good. 8 bits. Or a single octet, how many bits are there? In a single octet, if I'm talking about, how many bits? 8 only. Correct. So guys, if we're talking about this one, this is about the source port here. This is about 16 bits, destination port 16 bits, sequence number 32 bit. The sequence number and acknowledgement number is always about 32 bit concept. Bit, not talking about bytes, because even size is what? 20 bytes here. Yes, byte or octet are same Abbas. 8 bits. Okay. So source port, destination port, sequence number, acknowledgement number, header length. Okay. Reserves length over there. Then these are the some flags there. 6 to 7 flags we have about sync, about acknowledgement. Okay. Then about fin, then about your urgent one, then about CWR, congestions over related with that, ECE, so reset. So these are the some flags. In some headers, you will get it as a name as a code. In some headers, okay, you can see in some header, it will show you as a code here. Actually, I think it's code mentioned here. Can you see this one? This is code bits here. Code means we are talking about here flags. We are talking about flags. And how many bits are there? There are the 6 bits, guys. Okay, 6 bits. This is the window size. Very important concept. That is about window size. TCP checksum, urgent pointer, and options. This options contains a lot of things over there, guys, like MSS, about S, ACK. These 2 options are very important concept, which will place very important concept, which is about MSS means about maximum segment size, ki maximum in a single segment, and okay, how much the data we can transfer to. Okay, so those type of things. So this is about TCP header and basics idea about all these. So this is about TCP, this is about UDP, this is about UDP header, because UDP header doesn't contains all these things. So that's why 16-bit destination source port, destination port, UDP length or UDP checksum, that's it. No flow control, no, and this is what? Stateless protocol. This is what? This is your stateless protocol. Okay. And DNS applications, video streaming, and voice over IP. Guys, there is one more like some domain there in Cisco. I hope you are aware about that. That is about collaboration. Actually, actually collaboration is the combination of voice plus video concept. And before that, actually, guys, we had 2 different tracks. CCI voice was there, and then video was a different concept. But CCI was not there in the video, but in the voice, CCI was there. Okay, so that is about now they merge all these things and now they added into the collaboration. So the collaboration department, guys, mostly in the collaboration, TCP is not there. 95% we use UDP concept. Okay, voice over IP phones. Okay, so these are some voice over IP, like if we are using mobile phones and all, we are calling there. Okay, so this is about call by using voice over IP. Okay, so there are some phones there. Okay, voice over IP, so we are using that thing. So these things always uses your UDP applications. Segment and headers. Now, just tell me one thing. What is MTU and what is the default size of MTU? Please mention first thing. What is the default size of MTU and what is the maximum size of MTU? Please mention into the chat box. Maximum size also. I'm requesting to everyone. Maximum transfer. Okay, that's good. Mention the size as well. 1500 is what? Is that 1500 kilometer, 1500 minutes, 1500 like about, what is that actually 1500? Byte, bits. Okay, what is the maximum size? Okay. Okay. Okay, good. See. Now. Actually, FCS, this is because of the Ethernet. Okay, Ethernet header. The size is about, actually total is about 18 bytes. Okay, 14 in the, they are adding always in the starting, and this is 4 bytes in the end over there. This is the IP header, 20 bytes. This is the 20 bytes about TCP, and this is the payload. Payload means they are talking about data actually. They're talking about the data over there. So actually the 1500 is the size. Okay, that's okay. We can take it up to 1518 actually. 1518 also we can use it. But after that, if you will try to make it, then we need fragmentation. Okay, why we are saying ki it's 1518? By default, actually, it always shows as a 1500 only. Okay, because we are talking about MTU. So this is up to here. This is known as actually MTU, guys. This is not the part of MTU. Maximum transmission unit is not about this one. Yes, jumbo size and all that will come. So actually this is not the part of the header, but still if we are talking about MTU size is 1500, but in some books and some documents, okay, when I was going through all these things, you will mention there if the MTU size is 1500 plus 8 plus 14 plus 4, which equals to 1518. Why this 14 plus 4 they are adding? Because they are considering, okay, and according to them, this is also the part of MTU-MC. Ethernet header, which is about 14 bytes plus 4 byte, so 1500 plus 18 equals to 1580. In some books, guys, you will get MTU sizes up to 1518 also. But once you go through the RFCs, then you will get it as a 1500. Okay. But the thing is, okay, that is 1500. Okay, we are considering it 1500 because plus 4 and 4, 14, this one we are not considering here. I'm just taking it as a this one according to RFCMY. Okay, and according to some document, it will be like about 1518 days. Okay. I'm going through the RFC concept and what is mentioned in the RFCs. 1500 is the size. This is your MTU, maximum transmission unit. That's good. The thing is, when we are using MTU 1500, this is total MTU, which contains your TCP header plus IP header. This is about 20 bytes. This is about 20 bytes. So 20 plus 20 is what? That is about 40. So it means 1500 minus 40, 1460 is about your data actually. Or payload you can send. Means this much data you can send, guys. Okay. Just some time back we have discussed there. TCP header size is about 20 to 60. Okay. Just consider if we are using 20 to 60 and just consider right now, this is 1460 plus IP header 20 and plus 25 is my TCP header. Consider. So it will become what? 1505. So if it will be become 1505, so means that is known as now jumbo frame. This is about jumbo frame. So guys, what is the solution here of this jumbo frame? Anyone? Because on my router, I have mentioned here from this interface, I have to send MTU, but that MTU size is back to default size I'm using, and that is about 1500. So from maybe here we have mentioned 2000 bytes. So if we are getting 2000 from here, and once it's going to this one, so from here we can send only what? 1500 MTU. So then what is the concept will come? Then not segmentation. Segmentation is a different thing. We will come with the fragmentation concept. Clear? Don't use segment concept over there. Okay, segmentation is not there. We have fragmentation concept. Segmentation is a different thing. There's a difference between segmentation and fragmentation also. Okay, so then we have to go with a fragmentation concept. So that one also we have to discuss, but this fragmentation concept we will discuss in the IP header, not in the TCP header. If the other network size is greater than the current network, so then fragmentation will be there. So on that time, no fragmentation on another side. But if you will send the fragmented packets segments over there, okay, so they will get fragmented read only. So then reassembling concept will be there. So this is basics, very basics header is mentioned here. Okay, this is about TCP segment. This is a header. So this is about, guys, payload. Okay, this is also known as TCP MSS. What is the meaning of TCP MSS? TCP MSS means maximum segment size, the data, the maximum, how much like data I can send at the same time. So this is about that particular data concept, nothing else. Okay, so this is very basic things. Same header. This is a definition, means they are explained here about this is about the TCP. This TCP header explanation is there. Source port, destination port, 30 total 32 bit, then sequence number, acknowledgement number. All these things I have mentioned here. Nothing else. Okay. So urgent pointer and all these things we have to discuss, guys. So right now I'm not starting all these things. So many things are there. So tomorrow, how we have to start it? Where is this shit? If I'm talking about, because this was very basics today. Okay. Tomorrow I'll show you from syllabus. We will start from three-way handshake. Okay. What we will do tomorrow, we will use any two routers on the GNS or maybe on Eve. Okay. And 10.1, 10.2, we will do the telnet and we will capture the packet and we will save the packets, because daily we have to use that packets. Then from tomorrow, first of all, we will start with the three-way handshake process. We will discuss about that. In the three-way handshake process, different possibilities out there. Once we are doing the three-way handshake process, what is active open, what is passive open? So means before three-way handshake process, we have to go with active and passive option. Okay, what are these options? How to use, why to use, where to use, what are the things over there? Then three-way handshake process. Into that, in the three-way handshake process, we have four-way handshake process also. Okay, so these are some possibilities we have. So we will discuss about all these possibilities. So tomorrow we will try to finish this portion, guys. I think it will take 2 days, because we have to discuss sequence number into that. Identity sequence number, which is also known as random number. In interviews, they can ask you about the random number also, they can ask you sequence number also, and they can ask you identity sequence number also. So actually the thing is same. Okay, so guys, from here we will start tomorrow. I think it will take 2 days only, because so many things are there. ISN will take even 1 hour exactly, maybe more than that, because how they start with the segmentations and all. And before that, TCP sockets. Okay, what about the segment? What is the segment here? Okay, so all these things, guys, we have to discuss actually. Now, so about this one, we will discuss what is about TCP, what are the segment, what are the sockets, okay, what are the windowing and all. So all these things, guys. And what is window here? Window also, let me define one window keyword also here. What is window? So all these things, guys, we have to discuss. So in the upcoming classes, these two things will be there. Okay. Tomorrow I will create, actually today only I'll create this one. If I'm the network size. Okay, so tomorrow, today I'll create one folder actually on the drive, and that I will share with you guys. Okay, so that you can download the videos there. That book also I will upload there. For that I need your email IDs. So please mention your email IDs in the chat box so that I can copy and then I can send it to you the access there. Access I'll give you tomorrow only, tomorrow after the class. Just send me your email IDs. Today's session, this was a very basics. There was nothing new, okay, because you are aware about all these things, but just one revision was required. So that's why I have started like this way. So in the upcoming classes, okay, so many things we have to discuss. Congestion management, timeout retransmission, data flow windowing, congestions, keep alive, very important from this one. So I'll try to mug up the things within the 20 hours only. I'll try, otherwise if it will be more than that. So I will cover according to that also. So maybe on Saturday, Sunday also I can make the session there. Maybe we will change the time if you have some other sessions and all. Okay, because coming Monday now I have one Palo Alto session. So I'll try to finish before that only. But let's see. Mail IDs are done. Guys, if you have any doubt, if you have any questions, so you can ask me. Otherwise, see you tomorrow and we will start it tomorrow with the things. Don't miss your next classes. Okay, that is very important. Today, this was very basic things, but tomorrow will be at packet level. Any another one? Just about mail IDs, any other guys? Please send me in a single go, guys. Okay. Okay, guys. So then, guys, see you tomorrow, the same time, 11:30. Okay. Okay, guys. Bye bye. Take care. Thank you for the day. See you tomorrow.